Welcome back. This lecture is the Power Electronics seminar for the G30 International Program in Nagoya University. Today's discussion is a gate drive circuit, sixth lecture. And last lecture, I have mentioned the resonant phenomena, basic circuit topology, circuit principle, and using that principle, we can understand the gate drive circuit. Okay, let's discuss. And this is a total system of the power electron system using the analog circuit. Today's discussion is here, gate drive circuit. This gate drive circuit is here. Here. This one is a gate drive circuit. Why required this gate drive circuit? Because mentioned the last lecture, this power neutral electric lines signal is the 0 and 15, 0 and 15 pulse voltage, 0 plus 50 volt. We call the PWM waveform. And output voltage of the gate drive circuit. How about the output voltage? Almost the same. This. Almost the same waveform. So, why required gate drive circuit? We think it's enough for the output power of the comparator of this one. Oh, okay. This one is using the power source is 15 volt and 0 volt. So we can obtain the 0, 15 volt pulse, PWM pulse. Why require this? Because our target of this output voltage is driving the power semiconductors. Let's look at the power semiconductor symbol. Usually the bipolar transistor, we will use this, like this one. But IGBTs, or most IGBTs is the symbol is here. And most FETs, FET って君らわかるかな? Famous power semiconductor switch. Their semiconductor devices operate for the switch for using the saturation performance they have on. And here is for turn on of this switch. Input the PN junction voltage. In case of the PN junction voltage over voltage 0.7, and current flows through like this, flows through, turn on, on this switch. The switching signal is the current, this current. Current amplification is about 100. In the Toshiba's, for example, the Toshiba's 2SC185, this mode is the current amplification is around 17. So usually we treat the current amplification is around 100. If this is just image, if current flows through the 1 ampere, the switch current power line current flows through the 100 ampere. This is operate for the switch. However, this type of the switch is a voltage operation. Input the voltage, current flows through. We call that threshold voltage. Threshold voltage means some voltage, threshold voltage, 0 volt threshold voltage, take over this threshold voltage for the gate drive circuit, the switch turn on like this timing, okay? That one, the threshold voltage. Over the threshold voltage, current turn on. The same. Over the threshold voltage, current turn on. This voltage gate base power semiconductors operate by voltage, gate voltage. However, this gate source side, between the gate both source side, there is a capacitor. That is a connection directly to the gate source, this line. However, in case of this type, this line, gate side and power side is isolated. Gate line and power side is isolated. Conduction material isolated. This means occurred capacitor. This means occurred capacitor. In this case, isolated. So we can look the gate source line mean the capacitor. Okay. So let's consider this gate drive circuit. We must look to the including this power semiconductors. Okay. In case of the turn on term and turn off term, let's consider each voltage mode. Okay. First, what is the input VPWM. VPWM equal 15 volt. The equivalent circuit How about the equivalent circuit of the gate drive circuit? Please consider that one. In the 15 volt, current, in case of the positive side, power line, current cannot flow through this one because the upper side semiconductor we call the NPN, N-channel bipolar transistor. Lower side transistor we call the PNP. PNP type transistor, bipolar transistor. How to operate that each devices? In case of NPN devices, NPN is the N semiconductor, P channel semiconductor, N, and connected the gate side and at the P. Okay. PN means that we look the diode. Diode can flow through the P side to N side. In case of the PN junction voltage applied between each side voltage side, 0.6 to 0.7 around. Okay, so we can flow through the current PN side, P channel to N channel, P channel to N channel. In this case, we can flow through this one. In case of the flow through this one, we can treat this NPN channel for the switch, active switch. Okay, PNP, PNP. So PN junction flow through this one. So PN flow through here because the P we can flow through the PN input to the voltage. So flow through here, current flow through here. We can treat this PNP transistor for switch like this. So how about the 15 voltage PWM voltage side? Positive side, but however the NP side cannot flow through because there is no current flow through PN junction. So that we cannot flow through here, so we can only here. PN junction, this upper side is a 15 voltage, higher than the threshold voltage of the PN junction 0.7 over. So we can flow through the little current, but the flow through right here. こっちに書くか。Flow through voltage, flow through here, ground. Okay. In that case, current flow through, switch current flow through here. High current flow through from the power source line. This is a power supply systems. And in that red line, high current equivalent circuit. Please analyze this one. Okay, we can remove here. Okay. Please back to the movie. Okay. Let's consider the equivalent circuit of the input VPW voltage is 15 volt. This gate line is the power source. Power source means this one, and this one operates for the switch. So switch is turn on, and this power line is connected to the resistance, and we can look to this power gate source between we can look the equivalent component is the capacitor, so that we can look the capacitor. Equivalent circuit, okay. Turn on, current flow through from the power line, flow through the resistance, capacitance. Last lecture, we have mentioned how about this current, T equals 0, turn on, this one, gate T equals 0, give VCS, VC is 0 in case of the T equals 0. How about this one? This circuit. Transient phenomenon. We can use this circuit analysis, okay? And in case of the VPWM equal VPWM equals 0 volt. How about the equivalent circuit of the gate drive circuit? Please consider. We mean the V gate source, gate side, source side, V gate source power line. Because important is the V threshold voltage over or not. So the important point is the V gate source voltage is, how about the V gate source voltage? This one is a gate drive circuit output voltage, that means. So that we must look the V gate source voltage, okay? Please consider how about V gate source voltage. In case of the turn on, this PWM, VPWM, VP、一緒に書くか。一緒に書くかね。こっち側にね、VPWM って書いちゃうか。In case of the VPWM, 15 volt, 0 volt, 15 volt, 0 volt, cycling. Okay? How about the VGS? Please illustrate the voltage. これ T ね。Turn on. T equals 0, turn on. VGS, this means the VGS equal VGS, turn on. Transient phenomenon. we have already studied. So transient turn on over constant line. Transient turn constant area. Okay. Yeah. 0. Focus to this term, the transient is here, and 15 volt, 0, like VGS, VC equal this one. Already you can study it. This is this term, this term is here. Okay, the constant one. How about the pyramid Z equals 0? 0 line is already charged 15 volt in between the gate source voltage. Okay, so how about the equivalent circuit? Gate source voltage, and this point line voltage is down to the 0. The current cannot flow through like this. And we can use the charged energy or the gate source voltage. And the charged voltage, this charge flows through first time flows through like this, PN junction to the voltage, because this line equals 0, ground side, so the 0. Okay. Detail is the PWM output voltages are here, and open collectors. In case of the open collectors comparators, connected to the 0 directly, so directly flow through current is here. So this current is here. Okay. This is not essence, one, but detail operation is here. But please consider this line is this line is the ground side. So the current flows current flow through like this, and in case of the current flow through PN junction, the high current flows through here. This current is come here where the current flows through here. This current flows through the charged capacitor of the gate source voltage. Okay, this charged voltage change to the current flows through like this. Okay, this is a turn off line, and equivalent circuit is a charged gate source capacitor, switch, turn on, ground side. This one, T equals 0, VC, T equals 0, VC equals 15 volt. This is the first condition. And turn on this switch, turn on this switch, turn on this switch, current flows through here. Current flows through here. And the gate source voltage is lower and lower. First, 15 volt, lower t equal infinity, 0, lower and lower side here, and low. Focus to this term, 15 volt, 0, like this. So VC equal here. So the VPW changed to the 15 volt and 0 volt, 15 volt, 0 volt in this cycle, voltage cycle. This gate driver circuit turn on and turn off. It changed, and VGS is operated for the turn on, turn off, turn on. Oh. Almost the same, almost the same. But the focus to these terms changed like this, okay? So back to the first question. Why we require the gate drive circuit? Why? Why we cannot use this one, this voltage waveform? Answer is that we cannot use this power line. Because charging the capacitor, for charging the capacitor, we can require the charge. That means the current, high current require. High current discharges, high current require. Where we can obtain the discharged, this current. This is a power source, this power source. Using the power source, we can obtain high current and charged and discharged. In case of this signal, we cannot obtain the high current because the electronic signal, this gate drive circuit is the gate of the electronic circuit and electrical circuit. Electronic circuit is considered only the voltage and little current. However, electrical circuit requires the voltage and current. So we must consider the current. So additional power source line is here required for the gate drive circuit. And for operating the power semiconductor device, turn on and turn off, for charging the gate source voltage. That's why we require the gate drive circuit, okay? The gate drive circuit essence is the power line and current required, okay? That is the important essence. Power electronics, many textbooks and many movies. That explanation is very complicated because they discuss the isolation and PNP side, NPN side, the opposite side discussion is included. But this one is the essence of the power line, gate drive circuit. Technologies, if you'd like to learning the technology, essence is very important. Essence. Other additional know-how and additional variation, isolation, why require the isolation, why require the NPN, PNP side, NPN side, or other, and other gate drive minimum type. Isolation type is the photocoupler and transformer, and capacitor side. Capacitor type isolation is usually applied from the Texas Instrument company applying, and Japanese many for silicon carbide most FET driving is suitable for the transformers isolation is good matching, but that is a know-how, and the additional discussion. But the essence is important. Essence is here. Why required gate drive circuit? Please understand this. Why? Later you can learn other discussion. But this is the basically operation. So please understand today's lecture. Okay? Okay. Let's see the next lecture. Thank you.